mathematician. Hope you're doing good. I am Mohini. Today, let's begin our journey into mathematics by discussing set theory. One of the most common questions students ask before starting any topic is, why should we study this? And with set theory, the question feels even stronger. We don't use this in daily life, so why study it? But the truth is, we use set theory in our daily life more than we realize. Let's understand this with simple examples. In our homes, we organize things in groups. Plates in one cabinet, utensils in another. Each group is a set. When we combine all this, it becomes dinnerware. That's a union of sets. When we find common items like spoons used for both cooking and eating, that's an intersection. Even grocery lists, fruits, vegetables, dairy are simply subsets of a larger shopping set. On social media, when you see mutual friends on Instagram or any other platforms, that is nothing but the common elements between the two sets, friends. In surveys, when we ask people who like coffee, tea and milk, sets help us find people who like coffee and tea but not milk, people who like only one drink, people who like all the three, and so on. Another example is your music playlists. Your music playlists are also sets, collection of songs grouped by mood, language or genre. So yes, we use set theory in daily life constantly, even without realizing it. Now, let's move to a deeper reason. Set theory is the foundation of modern mathematics. It provides a clear and logical way to define and organize all mathematical objects. For example, natural numbers can be defined as a set starting from 1. Functions are defined using sets. We learn about functions, like how to define functions using sets, in set theory that we study now. And the mathematical spaces are also built using sets. So we study about the spaces in detail in higher classes. Set operations like union and intersection allow us to create new sets in a systematic and a logical way, not randomly but with structure and rules. This systematic structure is what makes mathematics consistent and powerful. Different branches of mathematics use the same set-based language. Probability uses sets for events, topology uses open sets, algebra studies groups as sets with operations. So you'll study probability here and higher topics like topology and algebra in advanced classes. But all of them are built on set theory. So why did mathematicians invent set theory in the first place? Before set theory, mathematicians struggled with vague ideas of infinity and continuity. This caused confusions in calculus and series. Earlier, mathematicians believed that all infinities were the same or all infinities were equal. Set theory proved this wrong. It introduced precise sizes of infinity, that is nothing but the cardinality, strict logical rules, nothing but the axioms, a formal structure that avoids contradictions. This brought clarity, consistency and stability to mathematics. In the real world, set theory is used in computing, databases, algorithms, data structures, and in logic, that is proof systems, reasoning models, and even to avoid paradoxes using axioms like ZFC. Without set theory, mathematics would lack structure and logical consistency. I will definitely explain how set theory is connected with probability and continuity when we start discussing about those concepts in future videos. That is why we study set theory first, because it teaches us how maths is organized, how concepts are connected, how logic works, and how systems are built. By learning set theory first, we build the foundation needed to understand all future topics clearly and deeply. And that is why we learn set theory as a first chapter, not just as a topic, but as the language of mathematics itself. ಧನ್ಯವಾದಗಳು. Bye.